Okay, hopefully this is going to work on a remote desktop. All right, so what I have here is a software called Kanban. It's not a professional class. It's very sort of amateur, hobbyist, fairly inexpensive piece of software that actually is a 2.5D software that generates G code for CNC machines. So what I have shown here is, remember I need to cut a slot down middle of a new aluminum plate that's 3 inches wide by about 8 inches long, and I need to cut this right there. So the first part is the in the machining section to define the size of the slot, the stock, and the stock here, stock size is 8 by 3 by zero point 0.4 depth, and this is the offset compared to the 0. So I just want to make sure my 0 was at the beginning of my milling operation, and it'll be very easy for me on the mill to actually figure out the exact middle right there. And this is 3 inches, so I'll bring it up to 1.5, and I'll zero the mill on this point and start the milling operation from there. So the box that I drew right there, drawn in red there, is 0.2 inches height by about 7 inches long, and it's got rounded corners right here, and the rounded corners are the width of the bit I'm going to use, which is a 3/16 bit. If I want to have this square, I'd need to use a broach, or it's kind of hard to make something square out of a round bit, no matter what size of bit. So I've tried this in the past, and then do something with a smaller bit, and it might as well live with the little rounded corner right here. All right, so what you see there is, if I show you in 3D now, this is the stock, right? So this is the thickness of the stock, and here's the slot I drew. So then I'm going to use two machine operations. First, I'm going to make a slot here at the depth of the stock, a little deeper actually, and that's going to be the first pocket. And I'm going to make that pocket right there, and these are the parameters of the pocket right there. What's important is it says, you know what, you're going to do a pocket here by increments of 500 of an inch, so you're not going to go all the way, try to cut it all the way through and go across, because that's going to break the bit, and the machine I have is just not strong for that. So you're going to make, this is the increment, this is the feed rate, 8 inches per minute, so that's the speed at which the bit's going to move across. And the plunge feed rate is the speed at which the bit's going to go down, because every pass is going to go deeper and deeper. And what I'm saying here is this is going to be a roughing pass, and I will do another finish pass. And the reason for that is because this is going to be a conventional milling. There's a certain direction to milling. The bit spins in one direction, and the way it grabs on the stock or the material, there's two ways. Either you go one direction, or you go the other direction. And the conventional direction is just more aggressive. You could take bigger cuts and so on, but it doesn't leave as nice of a finish. So I'm saying do a roughing pass and leave a 0.005 roughing clearance. So when this is done, it's not going to be 0.2 wide, and it's going to leave out like 5,000th of an inch on each side. And I'm going to do this with the second profile right here, and that's going to take care of the final pass that's going to be done using climb. So let me show you the toolpath. That's kind of interesting to see. So let's show the toolpath, and what's shown here in blue, and I'm going to move in quite a bit to show you what that looks like, is the toolpath. As you can see, this is 0.2 wide, and the bit is 0.185. And why am I not making a slot 0.185? Well, I learned that if you try to cut a slot that's fairly deep compared to the width of the bit, and you actually expect that the slot is going to be exactly the size of the bit, there will be no room for clearing the material. You're always better to use a smaller bit, and somehow move up and down and have some clearing room. So in other words, instead of having the two sides of the bit trying to clear material simultaneously because the width is the same size as the bit, you're better to clear only on one side, and that's what you see right here. So, so basically the bit's going to start here, and it'll move up there, clear, and move a little bit this way, and just enough to clear material. And it's going to go down, make 1, 2, 3, 4, 5, 6, 7 passes, 8 passes actually. And what you see down there, the bigger one that I'm showing right there, the wider one, the wider blue, that's the second profile operation. And you see it's going the reverse direction. That's going like a climb milling. It should make a very, very nice finish. All right. So obviously what you do is you generate the G code when you're done. You say generate, produce a G code, and that's what Mach3 reads, this G code. And so I just did that. And what's interesting is instead of trying this on the mill directly, I could try it on a virtual mill. Alright, so I'm going to do this, and here's the virtual mill. It loaded the G code that I generated down there. So here's a piece of stock that I have, and I can run it full speed, meaning like accelerated, and it'll just go zoom and do all the cuts, or you could go step by step if you want to see. But this is a very simple operation, so we'll just run it very fast, and there you have it. So let me move the stock around, and you can see that so what you have is a slot down there, and that's exactly what I was looking for. Right, you see that, and the bit is right here. What's interesting is you can make a look at a section cut, so I can actually go like this and say take this out and take a look inside. So that's kind of convenient. So you can look inside. Sometimes you make a lot. This is a very simple operation, but if you make more complex operation, then you can do some measurements. And so for example, if I want to know what's the width of this, even though I plan it to be 0.2, sometimes you could be surprised what it turns out to be. But so let's take some measurement. And the first measurement is the width there from this line to that line right there, and it says there you go, 0.2, exactly what I was aiming for. The other thing that's kind of nice here, it'll tell me here that machining time for this is going to be about 14 minutes. And then it gives you like the amount of volume of stock removed that you're going to remove. You're going to remove 0.4998 square inch of material. I don't know. I guess that's probably something that has got a professional probably figured out. For a professional, this is much more important, because if I were a pro, I'd probably accelerate this. I'm sure my machine could do this in, I don't know, 3-4 minutes if I were a lot more aggressive, but I'm not in production mode. I don't care if it takes 15 minutes. I mean, it takes me forever to prepare, and it took me a year to get this project. So I'm not going to like push the machine to do this in 3 minutes versus 14 when it took me a year to get here. Alright, so I hope you enjoyed this. Next video will be showing you the actual cut, and sometimes there are some nasty surprise, and so hopefully it'll do the right stuff, because the part here, even though it's simple, it's had a lot of machining on this part so far, and if I crash or mess it up, well, it's gonna be a lot of work getting it back to where it was. Plus, I don't have the material for to do it again, so I'm not sure I got enough aluminum to do this. All right, take care.